Good morning, Year 2. Our fact of the day for today is 10 times 2 equals 20. So I've got a picture here of 10 twos, and actually that is an array because you've got 10 twos. There's 2 along the top and then there's 10 down the side. So 10 times 2 is 20. Now if you were working that out, you probably would not bother to count in twos. You'd probably do it as 2 times 10 equals 20, which is what this array is showing. So you've got 2 there, and then all along there you've got 10, because that's much easier to work it out, 10 and 10, instead of going 2, 4, 6, 8 all the way to 20. So the opposite, the inverse fact, you'd put 20 first, and if you divide 20 in 2, you get a 10 and a 10, or it's the same as saying if you divide 20 into 2s, like in this picture, you get 10 twos. If you divide 20 into 10s, you get 2 10s. Now, the mega facts, this is where it gets a bit confusing because you've already got 2 zeros happening. So you need to be very careful with your zeros. But the first one, I think you can all answer this one. 2 times 100. I put the 0 on the 10 there. 2 times 100. And that would be, of course, 200s. So that's not too hard, is it? So you can just swap the two numbers. 100 times 2 would also be 200. Let's change the 2 now into a 20. So 20 times 10 would also be 200. And there you've got the 0 pattern. So you've got the 2 zeros on that side and 2 zeros on that side. And so then 10 times 20 would also be 200, but you do need to make sure you've got the right number of zeros. So if we're dividing 200, if you divide 200 in 2, you get an 100 and an 100. And if you divide 200 into tens, you get 20 tens. How else could we divide the 200? Divide it into 20s. And there would be 10 20s. Or you could divide it into, which one's missing? We've done 2 into 100s. How many 100s are in 200s? There are 2. Now, what could we do to make a really mega one? We could do, let's make a really, this is an easy peasy mega one. 2 times, what's that number there with 3 zeros? Sometimes a little comma helps. That's 1,000. So what would 2 times 1,000 be? That's quite an easy mega fact. Now make sure you've written those down in your maths book. First, we're going to look at some of the questions that I asked you yesterday to think about. So up here we've got what shape are arrays. Now you've probably noticed by now that most of them are rectangles. They have 2 short sides and 2 long sides. But we found out that some of them make squares, and those are square numbers. If you've got a square number and you arrange that number of counters, it can make a square. Now the next question is, will they always be this shape? So we know they're not always rectangles, they're sometimes squares, but don't forget you can also have a line that's a rectangle. So that one there is one set of 4, so it's 1 times 4 equals 4. And some numbers will only make a line. If I add one more, 5, that with 5 counters you can only make an array that's a line. So down here it says how many number sentences for each array. So most arrays have 2 times and 2 divide, although sometimes if it's a square number it's double the same number, so you can only have 1 times and 1 divide. And even if it's just a line, you've still got 4. So this one up here would be 1 times 5 equals 5, or 5 times 1 equals 5, and then the divides would be 5 divided into 1s equals 5, or 5 divided into 5s equals 1, because there's only one 5. And this question said, will the same number of objects always make the same array? So remember, when we investigated 12, we found out that that's not true, because you could make 2 times 6, or you could make 3 times 4, or you could make 1 times 12. So sometimes the bigger numbers can make lots of different arrays. So you might want to try that with 24 and see how many different ones you can make with 24. Now this one says, could you make an array with 11 cubes? So hopefully you've worked out now that if you do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you have got 1 times 11. So yes, you can, but you can only make that line with 11. Now you might start to think, oh, is that because it's an odd number? Because you can only make a line with 7. Remember 5, you could only make a line. 3, you could only make a line. But then remember there's a number like 15. And for that one, you could do 3 5s or 5 3s. So it's not to do with it just being an odd number. It's a different sort of number. So that's a challenge for you. Maybe you could ask a grown-up, what sort of numbers can only make an array in a line? Because they have a special name, a bit like square numbers have a special name. So this week we've been thinking about arrays. Now here's some of the pictures again. You might have seen some of these before. So we've got this one at the top. We've got rows of 2 and there are 3 rows. So 3 times 2 equals 6. This one down here we've got a row of 6 and we've got 2 rows. So 2 sets of 6. That's 12. This one here we've got 4 in a row and we've got 3 rows. So 3 times 4 equals 12. And this one here we've got 6 rows. 6 in a row, sorry, 1, 2, 3, 4, 5, 6. And how many rows? 1, 2, 3, 4. So that's 4 times 6. Now you might have to count those to work out 4 times 6. Or you could think of it as double this one. 2 6s are 12. So if we had 12 and 12 and we used our column addition, 2 and 2 is 4, 1 and 1 is 2. It's actually 24. That's a quick way of working it out. Now you've also had a go at making some of your own arrays. Now here it says we've got a 3, a 15 and a 5. So I'm going to see if I can make an array that matches those. Let's move those out. Let's try 3 times 5 equals 15. So how many rows do we need? We need 3 rows and there've got to be 5 in each row. So 1, 2, 3, 4, 5. It's quite hard to make these lined up. I think I will get a piece of squared paper to do the next bit. I need another row. Now when we do this at school, we use those little sticky dots that you can get, the coloured dots, but we couldn't get them in time to go in your pack. So that is 3 times 5 equals 15. And because these numbers can move around, I can swap it over to show you some of the other facts. So for the divide, I'll move the 15 to the front, bring down the equals, and then here are the little numbers. 15 divided into 5s equals 3, or 15 divided into 3s equals 5. Let's have a look at this example. So we've got the big number is what I need to know is 12. And I could do 2 rows of 6. 2 sets of 6 equals 12. So we've got 1, 2, 3, 4, 5, 6. And then I need another row. 1, 2, 3, 4, 5, 6. And just like before, it shows you that the little numbers can swap and have 6 times 2. And if we're doing the divide, we put the big number first and then the little numbers. 12 divided by 6 is 2, or 12 divided by 2 is 6. So that shows very clearly how you can make the number sentences. When you get your pack, you've got a sheet that looks like this, and you can cut these out, cut the whole thing out. Don't make the mistake of cutting all the little squares out. So if you're going to cut it out, cut round there. Stick it in your maths book and then write 4 number sentences. Now remember, if it's a square number, there's a square number there, and there's a square number there. you are only going to get 2 number sentences. You're only going to get 1 times and 1 divide. So they look quite nice when they're stuck in your book. But remember to put them in the squared paper book, because then you can put all your numbers neatly in the squares. So once you've done the ones on the sheet, or maybe if you haven't got the sheet yet, our TRP is, can I draw an array on squared paper? Now I know some of you have been doing this already. I think I've seen some amazing things in Michael's book that he's already done at home. Now there's 2 different ways of doing this. I was talking about the sticky dots that we've used before. So you could almost draw things in the squares. So if I have a go at doing 2 sets of 3, I can draw dots in the square. So there is my 2 times 3 equals 6. And now I've got squares. I'm going to make sure I write my numbers in very, very neatly. But the other way you can do it, which is a bit more clever, is actually using the squares to help you draw them. So 2 times 3, that would be 2 squares down and 3 squares across. And then you make the little rectangle shape. And of course you can then colour it in if you want. It does look quite nice coloured in. You don't have to though if you're not into colouring in. I think you're going to get some new colouring things in your pack. So that is also a 2 times 3 rectangle. 2 times 3 equals 6. So you can have a go at the dotty one, but then I want you to try drawing, but you do have to use the squares. Let's see if I can do a bigger one. Let's try 3 times 4. So it means we go down 3, 1, 2, 3, and across 4, 1, 2, 3, 4, and then you fill in the rest of the rectangle. So that was 3 rows of 4. So 3 times 4, and I'm glad I've got a double-digit answer to this. The answer is 12, because remember, you don't squish 12 in one square. It's very important that you don't do that, because when we're doing our column method for addition and subtraction, you have to have each digit in each square. So the 1 10 can go in there, the 2 1s. So make sure each digit and each symbol has its own square. So that's 3 times 4 equals 12. And of course, there are 3 other number sentences you can write for that one. Now, maybe for some of you, this might be getting a little bit easy now. So I've got a little challenge for you, and that's to investigate some square numbers. So if you're able to draw them quite easily on the paper, I want you to carry out a little investigation into square numbers. So the first square number would be this, and the second square number would be this. Remember, you need to write the number sentences to go with them. Can I fit in one down there? No, I'm going to move over here. So that's the next square number. Oh, I'm not very good at drawing this. Don't use a ruler though. You do need to trace the lines. It's even worse with a ruler. It's almost impossible. So I've got, that's 1 square number. There's 1 in there. There's 4 squares in there. This one is 9. What do you think the next one would be? That's a 3 times 3. So now we're going to have to go down 4. 2, 3, 4. And then across 1, 2, 3, 4. Then all the way across there and all the way down there. And that, if you counted up all the squares, would be 16. So what would the next one be? So I want you to have a go at seeing how many square numbers you can find. And is there a pattern? Is there any way you can work out which the next one will be and how many it will be? Remember to write down the number sentences with it. So this one is 3 times 3 equals 9. And that one was 2 times 2 equals 4. This one was 1 times 1 equals 1. And this big one over here was 4 times 4 equals 16. So what would the next one be? What would the one after that be? And the one after that? And you might get to the stage where you don't need to draw them anymore, though you have got a whole big maths book of squares. So you've probably got room to draw quite a few. And I'll ask you later in the Zoom meeting, what was the biggest one you managed to work out?